Hi students, today we are going to see a good derivation, many times asked in the board paper, okay? Many students facing the problem with this derivation also. I will make it maximum simple, okay? What is the derivation is, derive the expression for the potential due to an electric dipole. Okay, the derivation is derive an expression for the potential due to an electric dipole. So a little bit writing required. So consider an electric dipole having a dipole moment. You know the dipole moment, right? P is equal to Q2A. So having a dipole moment P, okay. What we have to do is we have to find the electric potential at a point P. This time we are not mentioning exactly where is the point along the axis or perpendicular to the axis. This is a derivation suitable for all. Okay. So at a point at a distance r from the midpoint of the dipole. We can do the drawing now. You know that dipole having two charges, right? So minus q plus q at a distance 2a. Okay. Marking the distance between the charges 2a. Okay, so midpoint marking, one side A, other side A. Total distance between them is 2A. Now we want to talk about the point P. Okay, here is the point P, which is at a distance mentioned in the statement. We mentioned like at a distance r from the midpoint of the dipole. Okay, so this distance is r, small letter r. Okay. Now, when we do the derivation, we need the distance between plus charge to P as well as minus charge to P. So plus 2 plus Q to P is R1, minus Q to P is R2. Okay, because we remember how to do this type of derivation from chapter number 1. Yeah, because electric field due to a dipole we did already, but that was 2 times, one for equatorial, one for axial line. Here draw one perpendicular line from plus q to that distance, that what is that, midpoint to point P1. Now side of the small triangle writing, you remember, yeah, adjacent side will be writing hypotenuse into cos theta, and extend that line to the minus side, minus q side also, until it become that end become perpendicular to the minus q. Then draw a line from minus q, so 90 degree, they're perpendicular. Okay, vertically opposite angle, right? So theta is equal to theta. What is theta? Actually angle made by the point P with the dipole axis. So this side of the triangle also hypotenuse into cos theta, that is a cos theta. Okay, some other label we are used to, like d is this edge. We are not using the derivation but still writing. Okay, so what we want to do, actually this type of question, actually we do first potential due to first charge, then potential due to second charge, then total potential at P will be the sum of the potential due to first charge and second charge. Same logic we are going to apply now. So electric potential at P due to plus Q is the potential equation. V due to plus Q is equal to, that is V plus is equal to 1 by 4 pi epsilon 0 Q divided by distance between them square. What is the distance between plus Q and P now? R1. So R1, equation number 1. Okay. Similarly, we have to do for minus Q. So add one statement, electric potential at P due to minus Q is, same sentence what we did before for plus Q. So potential due to minus Q is V minus is equal to 1 by 4 pi epsilon 0 minus Q divided by distance between them is R2. From diagram you will get equation number 2. So what is the common logic? Total potential at the P will be due to the plus Q and minus Q. That means total potential at P due to the dipole is sum of these two potential. So that we are going to write now. So total electric potential, okay, total electric potential at P due to, okay, you have two options. You can write either both the plus Q and minus Q charge you can write, otherwise you can write due to the electric dipole is, both give the same meaning. So total V will be equal to sum of them, right? So V plus add with the V minus is equal to, substitute value now, 1 by 4 pi epsilon 0 q divided by r square, but r1, no r square, okay, q divided by r1 electric field in my mind, plus 1 by 4 pi epsilon 0 minus q divided by r2. Now anything you feel common, I can see that 1 by 4 pi epsilon 0 is common, also q is common. So v is equal to, common right first, okay, 1 by 4 pi epsilon 0, then q. So in q also we can write in the numerator, open the bracket, what is left, 1 by r1 minus 1 by r2, close the bracket. Okay, equation number 3. Now this is the time to write r1 and r2 from the diagram. There are too many methods by different authors explain how to find r1, r2. I am following the easiest one from the textbook. There are law of sine, law of cosine and all applied. Unnecessary expansion, because total mark of the derivation maximum 3 mark only. So don't go with the unnecessary derivation, unnecessary part, mathematical steps. So here, this, because of the dipole is always small, there is a small slanting distance considered as the straight distance. Okay, so look into the diagram, you will see that small letter r is equal to OC plus R1. Look into diagram, okay, OC plus R1. So OC take to left side, so R minus OC is equal to R1, or R1 is equal to R1. Look into diagram. Okay, diagram not loading now, this page. Okay, so R1 is equal to R minus, actually what is that component is, OC is A cos theta, side of that small triangle. So this is R1. Equation number we can keep separately to substitute in equation number 3 later. So equation number 4, this one. Similarly, we want to find R2 also from the diagram. Okay, again we write the same statement from the figure. Okay, from the figure, look into diagram. Okay, I suggest you to refer the diagram. So we can write like the total distance. What is actually the total distance will be the sum of the individual part distance, right? So you can look into the diagram and decide. Let me check the diagram. Okay, R2 distance is, R2 is the left side distance. Okay, R2 distance is OD plus R. Okay, OD plus R, ignoring that small slanting. Okay, then is equal to OD is A cos theta, again one side of that downside triangle, plus R. So R2 directly we got, no need to do the transpose. So R1 ready with us and R2 also ready with us. So see, almost the same, right? It will be same. When we draw, it is like a small difference feeling, but because of the distance between the charges in the dipole is so small, that can take like that, no problem. So R2 is equal to A cos theta plus R. That is equation number 5. Now this is the time to substitute this R1 value and R2 value in equation number 3. Okay, so let me write that one. Substitute equation number 4 and 5 in equation number 3. Okay, if you want one time, you can write equation number 3 here. V is equal to Q divided by 4 pi epsilon 0, open the bracket. Now here it is actually 1 by R1 minus 1 by R2. Okay, so 1 by R1 minus 1 by R2. Just copying the equation to get a connection with what is the actual equation. So substitute now V is equal to Q by 4 pi epsilon 0. Now inside the bracket start substituting 1 divided by, in the place of R1, copy from here, what is that? R minus A cos theta. There is a minus in the equation, minus that I wrote. Then 1 divided by, in the place of R2, R plus A cos theta, close the bracket. Okay, now the normal mathematics LCM work you know, right? So we are going to work on that one. Okay, Q divided by 4 pi epsilon 0, open the bracket, cross multiply. So right side denominator will go to left side numerator. So 1 into R plus A cos theta. Usually we will not write 1 into, right? So R plus A cos theta. Okay, there is a minus, because of minus second term write in bracket. Okay, because minus is there, that will make a confusion. So open the bracket and write r minus a cos theta, close the bracket, all divided by product of the denominators. So that means r minus a cos theta, close the bracket, into r plus a cos theta. Downside, do you feel any identity? R minus a cos theta, r plus a cos theta. Yes, matching with one identity, right? So we write that one using a minus b into a plus b. It is exactly like that, right? So a minus b into a plus b is equal to a square minus b square. So here a stand for in the place of r and b stand for in the place of a cos theta. So v is equal to q divided by 4 pi epsilon 0, open the bracket, start writing a r plus a cos theta, open bracket now, minus plus r will become minus, inside minus a cos theta will become plus a cos theta. I hope no confusion. So simple mathematics. Denominator, use the identity now. So it will be like a square minus b square. That means r square minus a cos theta whole square will be a square cos square theta. Till now okay, right? So we move to the next step. Cancel now. R and R cancel. Then a cos theta and plus a cos theta. Definitely it will be 2 times a cos theta. So v is equal to q divided by 4 pi epsilon 0 inside the bracket 2a cos theta, 2a cos theta divided by r square minus a square cos square theta, close the bracket. Okay. Now considering the special condition, actually derivation almost over, only one thing is missing, that is electric dipole moment we can identify from the equation. That later stage we can do. First we apply one condition. Suppose the point P is very much far away, that is if r distance is much greater than distance between the or midpoint to the charge distance a. If r square greater than, very much greater than a square, then a square term can be neglected. Okay. So v is equal to q divided by 4 pi epsilon 0 inside the bracket 2a cos theta divided by, what do we want to write? We said a square can be neglected, right? So just r square, close the bracket. Okay. Now this is the time to rewrite this equation to identify one component here. What component? One physical quantity exists. What is that physical quantity? Is electric dipole moment q2a, that is p is equal to q2a. So we know that q2a is equal to p. It is there in the equation. So we can replace these three together with one variable. So 1 by 4 pi epsilon 0, 1 by 4 pi, open the bracket. In the place of these three letter p we can write cos theta divided by r square. This is the standard equation for field due to an electric dipole. Now we can this customize for axial line and the equatorial line. Okay. But standard equation is this one, p cos theta by r square. Okay, right? Now I made it maximum simplified. Now special cases. What I am going to write the special cases are, one is if the point is along the axial line, other one is if the point is on the equatorial line. First case, special cases. Okay. First case going to write. So this time no need to do separated derivation. We are going to do only one derivation. We change the value of theta in the equation. First one, potential at a point on the axis or axial line. Okay. Potential at a point on the axial line. See, if the point is axial line, what is the angle you are expecting? Either right side or left side, yeah. So we consider right side for example. So theta is equal to 0. Axial line meaning is no angle exists with the axis. So cos 0. What is cos 0? 1, right? So v is equal to 1 by 4 pi epsilon 0 p cos theta divided by r square. Actually cos theta here is cos 0. We know that cos 0 is actually equal to 1. So in the place of cos 0, in the next step we will not write anything because into 1 it is. So 1 by 4 pi epsilon 0 p divided by r square. That's enough. No need to write 1. So this is the axial line equation prepared. One more we can prepare, that is the equatorial line equation. Okay. So second case, the second special case is potential at a point at a point, which point? Axial line over. Now only possibility is, actually any point you can consider, okay. For standard method, we are following the equatorial line. Even it is at 30 degree, the above equation is suitable to do calculation. Potential at a point on the equatorial line. Equatorial line. Equatorial line 100% one option only, that is 90 degree. Yeah, put theta is equal to 90 degree. Remember, when we put theta is equal to 90 degree in the cos equation, cos 90 is 0. Cos 90 is 0. So V is equal to 1 by 4 pi epsilon 0 P cos 90, cos theta by r square. We will substitute cos 90 after this step, okay. Let me write here what is the value of cos 90. So cos 0 we already wrote in the previous case. Cos 90 is equal to 0. So in the next expression, what is going to happen, you see, V is equal to P cos 90, answer we will write. That means basically 0. 1 by 4 pi epsilon 0 P into 0, because cos 90 is 0 divided by r square. So the overall equation is 0. So V is equal to 0. What is the meaning of that one? There is no potential exist on any point on the equatorial line. So simple, yeah. Before, you may be thinking that this was one of the toughest derivation in chapter number 2, but actually not. When we manage it in simple way, derivations are very simple. Okay, let me write one note here. Okay, the equatorial plane of the dipole, is an equipotential surface. You know equipotential surface? The surface having the same potential everywhere. Everywhere 0 will come, right? So we can say it is equipotential 0. Okay. Okay, students, I hope the derivation was so simple. I tried my level best to make it simpler for average and below average students, because there are some below average students messaged me like, can you explain this derivation? Okay, students, thank you. Have a nice day. See you in the next video. Bye.